Hello and welcome to SNR Tech Bytes. Today I want to talk about the volume controller system that I built for my PC. This is actually based off of the Deej software written by Omri. I think I'm pronouncing his name right. I've got it linked down below for you to take a look at if you want and use it yourself. It's an awesome software that basically lets you interface an Arduino with your PC to control volume with whatever you want. Now here I actually have encoders, and the reason I'm using encoders instead of potentiometers like most people use in this is I wanted that tactile feel, but one of the other really big benefits is these are click encoders. So I get a button on each channel. So I can actually mute the channels just by clicking the buttons if, I don't know, let's say an ad starts playing on Chrome and it's way too loud. I just click that button, shuts it off. The way I'm doing the lights here is I actually have neopixels underneath each one of these, and the way I have that light coming through like this is through multicolor print on my MMU with my Prusa. Now you could do this without the MMU if you wanted it. It does require 2 filament changes, but you could do it manually pretty easy. Just line up the filament changes where you need them to be. I've got the Thingiverse file for this front plate as well as this box that lets it kind of just stand up, work fine. That banding is because of some thermal issues I had on my printer. That's since been fixed. I printed this in 2 parts. The first part is this piece that sits on the desk. It's got an opening for the front plate to seat inside of, and it's got these 2 raises that actually fit my Arduino Maker Zero, which is what I'm using to control this whole system. The second piece is the front plate here. There's the 5 holes here for the encoder, and on the back side I've actually got standoffs to hold the encoder in place. A lot of times when I'm printing something I try to use as little hardware as possible. Unfortunately you do need 4 screws, and the reason for that is because a press fit mechanism wasn't working very well with this system, and I think the reason for that was just because there's too many wires that end up getting packed inside of here. Encoders have a lot more wires. The next part is my LEDs here. So I've got all 5 LEDs here with just a servo plug on them to connect it to the rest of the Arduino, and each one of these are Adafruit single PCB neopixels, and what these do is they press right into the standoffs where the white piece normally is. If they don't fit very well, if they're a little bit too loose, you can take a hairdryer or a hot air gun and just melt the plastic just a little bit, get it malleable, and squeeze it together, and that'll give it a good pinch fit. The next piece I did here is the Arduino. As you can see, there's a lot of wires, and I really don't want to take this whole system apart because it is a pain to put back together. But if you were to do this yourself, basically the way I did it is I made 2 harnesses. So I have a 5-volt harness and a ground harness. You can see my solder jobs here and here. These harnesses plug directly into the VCC pin and the ground pin on the Arduino Maker Zero. And then each one of those feeds to each encoder. I also actually have the ground and the VCC plugged into the servo plug to power the LEDs as well. One thing is that the Arduino Maker Zero actually runs on 3.3 volts, not 5, and that's okay if you're just running 5 neopixels. These are all running on 3.3 and there's no problem. Now for each encoder there's going to be a total of 5 connections. You're going to have a ground connection, you're going to have a 5-volt connection, you're going to have SW, DT, and CLK. SW is your switch pin, so that needs to be plugged into a single pin on the Arduino, and then the SW and DT also get individually plugged into the Arduino. If you look in the software that I have linked on the SNR Tech Bytes GitHub, that will show you where I plugged each one in. You can use that if you want. You can basically kind of plug it into random pins if you want and just reprogram the software. This series of pins works well for me. I did find an issue where basically one combination of pins sometimes didn't work right, so I had to switch to a different combination. At least for the Maker Zero, this combination works fine. Now the way I actually put this inside of the case is I start by putting the front plate on. So I've already got the LEDs pressed in here, and what I'm going to do is I'm going to take each encoder and I'm going to put it in place. Now one thing that I did have to do with these encoders is actually bend all of the pins slightly, as you can see here. The reason for that is they were colliding with the LEDs. I'm going to flip it around and I'm going to put the washer nut combination on the front of these encoders. Okay, now when we come over to the actual desk stand, and you'll see that there's these two extrusions in here with a small slot in the middle. That's actually made to fit all of the pins on the Arduino. So what we're going to do is we're going to carefully slip the Arduino in upside down. We're going to kind of bend the wires out of place. And what I find is that leaning the Arduino at this angle kind of backwards and slipping it into those extrusions is the best way to get it to work. It does take a little bit of finagling to get in just right. Don't push too hard, you don't want to short any of the pins inside, but once all the pins go through the plastic, you can just push it down and make sure that you can see the micro USB there. Next, I'm going to take the LEDs and I'm going to hook it up to the Arduino here. I'm going to kind of carefully stuff all that together, and then I'm just going to put the 4 corner screws in. Don't over tighten because you are just tightening directly into plastic. So just until you sort of feel it grab. And that's assembled. Now we're going to throw the encoder knobs on. I just used the ones that came with the buttons. I liked how they felt and looked. You're absolutely welcome to 3D print your own encoder covers if you'd like. Alright, we'll plug this in and move to software. Okay, on the software side of things, this is the software that I wrote to interface. I'm basically using the vanilla branch of the Arduino code by Omri. And then I'm also using the encoder.h library as well as the Adafruit.h library. I'm not going to go through every line of code that I wrote, but just some important things here are going to be these 5 encoder values. So this is the pins that your CLK and DT are plugged into for each of your encoders. The last thing you might want to change is the config.yaml in the Deej controller. What I like to do is change the extension to .txt, that way it just opens right inside of Notepad. You could use Notepad++ to edit the YAML directly, but it's up to you. So what I have in here are just some games that I play. So the way this is kind of written is here's your slider mapping, which is just what each encoder is mapped to. So your master volume, I've got this one to Discord, Chrome, just like all of the icons on the front plate say. Number 3 is just general gaming, so I go in here and update the games all the time depending on what I'm playing that day. And then the very last one I have marked to Spotify, even though I'm just using a generic music symbol. This is important as well. Your COM's probably going to be different for your Arduino. Most computers default to COM 4. I have a number of Arduinos that I work with. So this particular Arduino was COM 3, so I just threw that in there, click save, and the encoders are noisy, so I definitely suggest changing noise reduction to high. I have put this as a YAML inside of the GitHub as well, so you're welcome to download this from there and use this one as a direct exchange. After you've made your updates, just close it and change the extension to .yaml and reload the DJ executable. For those of you that stuck around to the end, I want to provide 2 little sneak peeks of projects that I'm working on. This is a fully 3D printed RC airplane. This should be a fun little project that I'm hoping to release here within the month. This is actually designed by Eclipse Airplanes. They make probably the best 3D printed models I've ever seen. I also finished printing up the Iron Man chest piece along with a few other pieces. I need to weld them up, and you guys should be seeing a video about all of that soon.